In this video, we're going to look at how to predict the sign of a change in entropy for a system. So entropy is a state function. This means that the entropy change, or delta S, for a process or chemical reaction depends only on the initial and the final states of the system. So because of this, we can write an equation where we have the change in entropy for a system is equal to the entropy final minus the entropy initial. And note, here we are analyzing the change in entropy that occurs for a system. So if you had a system that underwent a chemical reaction or a physical change, this equation allows us to calculate the change in entropy for that process or chemical reaction. Now, if our process, our chemical reaction or phase change occurs under standard thermodynamic conditions that you can see here, well, then we just rewrite the formula, putting the little degree sign here indicating that we're calculating the change in entropy of the system under standard thermodynamic conditions. Now for reactions or physical processes that increase in randomness, these processes will have a positive delta S value. So if a system starts at low entropy, initial here is small, and it increases in entropy, so the final entropy is larger, then that process will have a positive change in delta in entropy for that system. Of course, if the reaction or process decreases in entropy, so it decreases in randomness or disorder, then our sign for delta S will be negative. So if we start off with a relatively high initial entropy and the process the system undergoes a chemical reaction, let's say, where the final entropy is less than what we started with, then of course we would have a negative delta S sign, indicating that we have less randomness and disorder in our system. So what are some examples of processes or reactions where we have changes in entropy? Let's look at some of these. First of all, let's look at phase changes. Let's say we started out, our system was in the solid phase. If our system goes from the solid to the liquid phase, then that change in entropy will be positive because we're increasing in entropy. If we go from liquid to gas, again, we're increasing in entropy, so our delta S for that system will again be positive. And the reverse is true if we go from gas to liquid or liquid back to solid, we're getting we're getting less entropy, so our entropy is decreasing and our delta S sign will be negative in these instances. So we can predict the sign of delta S for a system when we're undergoing a phase change. Also, for chemical reactions, we can sometimes predict whether we'll have a positive or negative delta S. Let's look at this reaction. Here our reactant is N2O4, and it decomposes or breaks apart to form 2 moles of NO2. Well, since we're breaking these molecules apart and we're increasing the number of moles of gas, well, if we're increasing the number of moles of gas, we're having more randomness and disorder. So we're increasing our entropy, so we'll have a positive delta S. If we have a reaction that decreases, we have a net decrease in the number of moles of gas, the sign of that entropy change would be negative. And finally, if we prepare a solution, let's say we dissolve a solid in a liquid, and therefore we form a solution. Anytime we form a solution, we're going to increase the randomness and therefore increase our entropy. So the sign of delta S for forming a solution will almost always be positive. The same thing occurs if we mix 2 liquids together. If we mix 2 liquids to form a solution, again, our solution, so our S final, will be greater than our S initial, and our delta S will be positive. So just looking at some chemical reactions or physical processes, we should be able to predict the sign for delta S for that system. So let's take a look at a problem. Look at each of these processes and see if you can determine whether the entropy is increasing or decreasing, and predict the sign of delta S for the system. Pause the video and give it a try. Okay. So for the first one, you can see that we are starting with 3 moles of gas and we're producing 2 moles of gas. So we have fewer moles of gas, so the entropy is decreasing and the sign of delta S is negative. For part B, we have a solid which is reacting to form a liquid and a gas, so we're increasing in entropy there, and the sign of delta S would therefore be positive. For part C, we have a total of 4 moles of gas, which are reacting to form 2 moles of gas. So the entropy is decreasing. The sign of delta S would be negative. Here we have hydrogen fluoride, which we're putting into water, aqueous, and it's dissociating. So as these ions break apart in solution, the entropy is increasing and delta S will be positive. For part E, we have a chemical reaction where we have a solid and a gas. So we have 1 mole of gas and we're producing 2 moles of gas. So therefore, the entropy is most likely increasing and delta S is positive. And if we're boiling water, well, if we're boiling water, we're going from a liquid to a gas. So we're having a phase change where our final entropy of the gas is greater than what we started with. So the entropy is increasing and the sign of delta S is positive. So be sure you can predict the sign of delta S if you're given a chemical reaction or any physical process.